Right, we are having with us the 2018 paper, November, of the IEB Assessment Matters Examination Mathematics Paper 2. 3 hours, 150 marks. We are solving all the questions today. Let's just see the first question. Right, so what we have is that in the diagram below, M is a point on the line that joins A and B. Here is M. M is a point, but is the midpoint. Okay, right. Find the coordinates of point M there. So how do we find the coordinates of point M? We proceed as follows. So in other words, to find the coordinates of point M, we take x1 plus x2. We divide by 2. We have y1 plus y2. We divide by 2. x1, y1. X2, y2. So x1 is 1 and x2 is 5. So you have that x1 is 1 and x2 is 5. You divide by 2. And y1 is here, is minus 1. y2 is 3. We divide by 2. Okay, we have 6 divided by 2, 3. This one, 2 divided by 2 is 1. Right, 2 marks. We are good. That is the midpoint. Here's the next question. Find the equation of a line perpendicular to AB that goes through M, the perpendicular bisector of AB. Okay, so a perpendicular bisector of AB is going to be, if you look at the diagram here, you have the line AB, and therefore there's a line that goes through like so. And it's perpendicular, but it divides into 2 equal parts. This line is called the perpendicular bisector. Right, so and we want to find the equation of the perpendicular bisector. So first we must find the gradient of the line AB. Right, so the gradient of the line AB, could just put a small note on the side. Right, we have the A and we have the B. So A has the coordinates, here they are, 1, minus 1. A has the coordinates 1 and minus 1. B has the coordinates 5 and 3. Okay, what is the equation of the perpendicular bisector? So first we must find the gradient of AB. What is the gradient of AB? Right, so the gradient of the line AB is seen as actually y2 minus y1 divided by x2 minus x1. So which is x1, y1, x2, y2. So y2 is 3, y1 is minus 1 divided by x2, which is 5, x1 is 1, then this is 4 over 4, and this is 1. So the gradient of the perpendicular bisector times the gradient of AB must be minus 1 because the perpendicular bisector, right, the perpendicular bisector is indeed perpendicular to AB. What is the equation of the perpendicular bisector? Okay, the gradient. Oh, that's what we want. And the gradient of AB is 1. So in other words, we put here the gradient of the perpendicular bisector times 1 is minus 1. This means the gradient of the perpendicular bisector and is minus 1. So we can use the equation y minus y1, which equals m into x minus x1, which means y minus. All right, so we take the point through which the perpendicular bisector, if the line AB is that one, the perpendicular line, it's there, It is a bisector. It bisects, and therefore it passes through M. What are the coordinates of M? M has the coordinates 3 and 1. So you put, at this point, you have x1, y1. They are coordinates of M. Y1 is 1, and the gradient is -1, and it is exactly x minus x1. And what is this? So if you simplify this, multiplying, right, so what we're getting here is y minus 1, which is this. X minus x1 is 3, which means y is, you distribute by the minus, so it's minus x plus 3 plus 1, which means y is minus x plus 4. Right, that is the equation. Minus x plus 4 is the equation of the perpendicular bisector. Equation of perpendicular bisector. What is the perpendicular bisector? Is a perpendicular line that divides the line AB into two equal parts, and therefore it bisects. Next question. Calculate the length of line AB. Easy. To find the length of the line AB, we consider the endpoints. Right, here is the line AB. You can write like this. So it is 1 minus 1, 5, 3. Okay, 1 minus 1, 5, 3. So AB, which is this one, x2 minus x1 squared, y2 minus y1 squared. So this is x1, y1. This is x2, y2. So let's continue and do the substitution. What is x2? It is 5, x1 is 1 squared. Y2 is 3, x1 is minus 1 squared. So we subtract and you get 16 here. You get 16 there. Okay, 5 minus 1 is 4. When you square 4, you get 16. And also this one, 3 plus 1 is 4. And therefore you have 16 plus 16, which is actually the square root of 32. Yeah, this is 16 by 2, which gives the square root of 16, the square root of 2, which is 4, the square root of 2. And 4 the square root of 2 is approximately 5,66 units. And that is the length of AB. Next question. Determine the equation of a circle that has center M and goes through points A and B in the form that one. Okay, so now in point D, you need to realize that here's a circle. It has center M. M has the coordinates 3 and 1. We saw that, right? It passes through the points A and B. So if it passes through the points A and B, let's look at the points A and B. Right, so if the circle passes through the points A and B, so yeah, it's like if it passes through the points A and B and it has center M. So in other words, you have that like so. So this is like A and this is like B. So A has the coordinates -1 and 1. Did you say 1 minus 1? Yeah, 1 and -1. So we have the coordinates of A, which are 1 and -1. The coordinates of B are what? 5 and 3. We have them here, 5 and 3. 5 and 3. So now you just, okay, what do we call the line AB that passes through the center of the circle? The line AB is called a diameter. It's called the diameter. So now, if you want to find the radius, you must just divide the these by 2. So what is the equation of this circle? So it's going to be x minus a, that is the formula, squared. Okay, maybe I can say put p here, because the examiner has already used a and b, so it can create ambiguity. So you can say y minus q, the square, doesn't matter the symbols using the formula. So obviously these are at m, so you have the p and the q at m. So you have a 3 squared plus y minus 1 squared equals, now the radius would be, you take the diameter AB, you divide by 2. So you're going to take this one, which is 4 the square root of 2. Okay, we found AB to be 4 the square root of 2. So you're going to take 4. So what is the radius, in other words, here? The radius is like AB out of 2. And it is 4 the square root of 2 out of 2. So yeah, it's 4 the square root of 2 out of 2. You square that. This is x minus 3. You square that. Y minus 1. You square that. 2 the square root of 2. So you square this. Y minus 1. You square this. You square 2, you get 4 times 2. If you square this one, it's x squared. You square x, then the next is x times minus 3, which is minus 3x times 2, minus 6x. You square minus 3, you get a plus 9. You square the y, it becomes y squared. Y times this times that, which is minus 2y plus 1, which equals 8. So what is the equation in this form? So, but we must transpose the 8 to the other side because there is a 0. The answer must have a 0 on the right-hand side. So this is actually x squared plus y squared. It's actually x squared plus y squared. Okay, like that. Okay, then we have minus 6x, like so. And then there's a minus 2y. And then you have 10 minus 8. 10 minus 8 is the number 2 equals 0. And this is the answer. This is the answer. Okay, if you look at D at E, for example, determine the values of K if point H lies on the circle. Determine the values of K if point H lies on the circle. Right, obviously we agree that the circle has the equation given. So what is the equation of the circle? We can take any of the forms, like we can take that one. We can take x minus 3. You square that, you can take y minus 1. You square that equals what? X minus 3 squared, we said it is equal to 4 times 2 equals like 8. Right, can have exactly that one. So obviously it is right, if point H lies on the circle, so the circle passes through point H, and H has the coordinates 4 and K, so you have X and Y, right? So what is X there? It is 4 minus 3, you square that, and then what is Y here? It's K. You square that equals 8. Okay, you just need to solve for K out of this equation, because if the circle passes through point H, you just get X and Y from H and substitute into the equation. You could use any of these. You could even use the last one, you know, or you can use this one. Okay. And then now, with that said, we are in business because what is this? This one here is actually K minus 1 squared is equal to 8. 4 minus 3 is 1. So you have that squared, which is 1, which is 7. 8 minus 1 is 7. So if this is the case, then you have K minus 1. Okay, so you have K minus 1 like squared equals 7. And then you have this. which is like plus or minus. So which is k minus 1 equals plus or minus the square root of 7. K. What is k? Right, solving making k the subject with plus or minus the square root of what? Of 7. So that is the answer. So y is 1 plus or minus the square root of 7. Determine the shortest distance of the circle from the y-axis. Determine the shortest distance of the circle from the y-axis. Right, so you need to think about this and analyze this. So obviously, the couple of things you need to sort of look at, you have the point A and the point B. 1 minus 1. B has the coordinates 5 and 3. Here is a circle, and the circle, whatever, something like this. It might be cutting the y-axis, yeah. So, but obviously you need to just cross-check that part. But what this is the coordinate axis, the x and the y-axis. That's just a rough sketch. So the question is saying determine the shortest distance of the circle from the y-axis. Okay, there's a point M here with the coordinates 5 and 3. 5 and what? No. 3 and 1, 1 and 3. Need to check that. What are the coordinates of M? Found that in the beginning. Okay, the coordinates of M are 3 and 1. So plug them in here. So in other words, the coordinates of M are 3 and 1. That is the point M there. Okay. Determine the shortest distance of the circle from the y-axis. Right. What is the shortest distance of the circle from the y-axis? Now, what is the radius of the circle? First, we need to find the radius of the circle. Right, the radius of the circle is, we did it here. The radius of the circle became AB divided by 2, okay? Because AB is like a diameter from boundary to boundary, from circumference to circumference, and then we said that divided by 2, and therefore the radius is 2 the square root of 2. So the radius is 2 the square root of 2. Right, so, but you must realize that the number 2 is the same as the square root of 4 and the square root of 2, so that this is the square root of 4 by 2, and 4 by 2 is the square root of 8. Okay. How far is M from the y-axis? M the center. The y-axis is here. How far is it? So M is 3 units away. Is 3 units away from the y-axis. Okay, because we have the coordinate that is 3 and 1. So yeah, it's 3 units away from the y-axis. By using the x component horizontally, is 3 units away from the y-axis. What is the radius of the circle? The radius of the circle, I'm mentioning that again. Right, you can write it in a couple of ways, but you can write the square root of 8 units. Or you can write 2 the square root of 2 units, the same thing. Therefore, what is the shortest distance? Therefore, the shortest distance of the circle from the y-axis is. Right. So in other words, what is the shortest distance? So you can take actually the two things. So it is how far it's the point M. The point M is 3 units, so that you'd have 3 minus the square root of 8 units. Okay, so it's 3 minus the square root of 8 units. So in other words, you have 3 minus the square root of 8 units. So you have that. 3 minus the square root of 8 units. Okay. So yeah, that's what we have. So they said determine the shortest distance of the circle from the y-axis. So to find the shortest distance of the circle, we're taking the 3 units, which is the 3 units away from the y-axis, that those according to the center of the circle, and then we subtract the radius, and then we shall get the actual shortest distance of the circle from the y-axis. We shall get the actual distance like a small little bit, and that small little bit is this one, the distance of the circle. So, and obviously now it's clear, therefore, that this circle does not touch the y-axis. Okay, I had not calculated before, but yeah, this further confirms it does not touch the y-axis. Okay, it does not therefore intersect the y-axis, this circle. Next question. Right, in the diagram below, circle O is drawn in the Cartesian plane. MN is a tangent to the circle. Okay, is MN a tangent to the circle, and is a point outside the circle with coordinates 11 and minus 5. So the coordinates here are 11 and minus 5. Okay, so you have those, yeah. And obviously you have the origin. All right, so write down the size of OMN. Write down the size of OMN. Right, so obviously we have that here. MN is a tangent. So if you have a tangent, and O is the center, so this is a radius. So a tangent is always perpendicular to a radius at the point of tangency. So this is the point of tangency. Point of tangency, or the point of what? Or the point of contact. Point of contact. So write down the size of OMN. OMN. Right, so that means therefore OMN is 90 degrees. Tangent. Why is it 90 degrees? Why is this angle not anything else? Why is it 90 degrees? Why is it not 45? Why is it not 20 degrees or 60? It's because we know in mathematics that a tangent is always perpendicular to a radius at the point of contact. So if the equation of the circle above is this one, then the coordinates of O are what? The coordinates of the center. Want to find the coordinates of the center? So we would have x squared minus 8x plus y plus 4. Like this, squared equals 9. Okay. So which means that you have x squared minus 8x plus half of minus 8, which is y plus 4. Right, so which means at this point you have x. Okay, half of this one is minus 4. You square that, y plus 4. You square these equals 9. So it means, therefore, we can say the coordinates of O are, okay, because it's negative, you take 4 here, and this one is positive, you take minus. So the coordinates of O are 4 together with minus 4. Those are the coordinates of the center of the circle. Right, so if the examiner would ask us like, all right, look, we added half the coefficient of x on the left, we must add on the right also. So you'd have this. Okay, so this is exactly half of -8 is -4, you square that is 16. And that would mean that you have x -4, you square these, plus y +4, you square these, equals 25. What is the radius? It is the square root of 25. 5 units. Right, determine the length of OM. Determine the length of OM. Right. We want the length of OM. Okay, we already got the coordinates of O. What did you get the coordinates of O? We got them at the bottom. They're 4 and -4. And we just need the length of OM. Okay, we also got the radius. What is the radius of this circle here? The radius of this circle is equal to, okay, we found it to be 5 units, which is the distance from the center to the circumference of the circle. We can easily find the length of, we must just find the length of ON. What is the length of ON? Right, so the length of ON, we can use the distance formula for that one. So, okay, so the way you're going to practice, you're going to repeat these questions, folks. Okay, so if you have O, 4 minus 4, and would be 11 and -5. 11 and -5. Okay, so this would be the actual length of the of the ON first, okay, before we get that. So let's find the length of ON. We're going to use the length formula, the distance formula, x2 minus x1, we square that. We have y2 minus y1, we square this. So this is x1, y1, this is x2, y2. So this is exactly, what is x2? X2 is exactly 11, x1 is 4. Square this. Y2 is -5, y1 is minus into minus that, which is square this. Right, if you do everything here, you realize that this is the square root of 50 units. And then now, if you use this, what do we have here? So this is the M, but there is an M somewhere here. And now the M is from is a point on the M is a point on the boundary, and N is sitting here. Okay, look here. Okay, this is the diagram. This angle is 90 degrees, so we can use Pythagoras theorem in this triangle. Is a right angled triangle, this one. So we continue. We know that this angle M is 90 degrees. So because the tangent is perpendicular to radius, we know the radius is 5 units of the circle. So now we continue, and we can be able to find the length of O, determine the length of OM. Okay, that's not switch the pointer a little bit. Let me see. Which length do they want here in C? Let me just check that, please. Oh yeah, okay. So yeah, okay, the length of OM is obvious anyway. So you're in part C, so you don't need to calculate a lot of things. Okay, it's not part C in particular, it's B. So yeah, you don't even need all this. I need to indicate that I've done a bit extra. So what is the length of OM? Okay, OM is the radius of the circle, and we got that there. So OM is equal to 5 units. Okay, distance from the center to the circumference of the circle, just 5 units. Then if you look at C now, the length of MN. Okay, now we're looking for the length of MN. So that is what we need to calculate. But yeah, we've already got the length of ON. What is the length of ON? And the length of ON is 50 units. right? What is ON squared? ON squared is OM squared plus MN squared. All right. What is ON is the square root of 50. OM is 5 squared. And then we need the MN. Okay, why is ON squared equal to OM squared plus MN squared? This is called Pythagoras. So that if you square this one, it becomes 50. 5 squared is 25. And this is MN squared. 50 minus 25 is 25. MN squared. Okay, we're interested in MN, so we can take the square roots, both left and right. Okay, we only obviously take the positive, okay, which is 5. 5 MN. The 4 MN is 5 units. 5 units. So yeah, they wanted the length of MN, and it's 5 units for a total of 4 marks. For a total of 4 marks there. Right, next question. Right, question 3 is on the same set of axes below. The graph of F is this one here. Here's the graph of F. Has been sketched below. Okay, we can see the sketch. What is the question? On the same set of axes shown above, sketch a graph of this one with x between 0 and 180 degrees. Okay, so we need to sketch the graph of 3 sine 2x. 3 sine 2x. So we have another function g of x, which is 3 the sine of 2x. So, okay, let's start quickly. So you can just take the points between 0 and 180 degrees. Like at 0 degrees, you substitute 2 times 0 is 0. Sine 0 is 0. So it's going to be here. Right. Next thing is you can just take, like, okay, perfect, 45 degrees. What is 2 times 45? 2 times, because for x is 45. 2 times 45 is 90. Sine 90 is 1. 3 by that. So it's going to be like 1 here. And it's going to do this. 3 by 9, 2 by 90 is 180. Sine 180 is what? Is 0. Okay. 2 times 135 is like, because x is 135, which is 2 by that is 270. Sine 270 is minus 1 using calculator. And 3 times minus 1 is minus 3. Okay. 2 times 180 is 360, and the sign is going to be a big 0. Okay, we have the green graph, and the green graph is the g function. Right, next question. So on the same set of axes shown above, sketch the graph of g of x equals this with x between 0 and 180 degrees. Okay, we've already done that. Determine the values of for x. F equals g if x is an element of the interval there. Right. So the f function is is cosine 2x, and the g function is 3 the sine of 2x. Right, you can divide both sides. So you have cosine 2x equals 3 the sine of 2x. You divide by cosine 2x. 1 equals 3. This is the tangent of 2x. Divide by 3, tan 2x. Tan 2x. Okay. Reference angle. Arc tan of 1/3, which is 18,43 degrees. So this is the reference angle, but we're looking at parts where axes between these and these are equal to each other, but these are equal to each other. These two functions are equal to each other when the tangent is positive. When is the tangent positive? So we have the cast rule, the cast diagram. We have the cast diagram. Right, the tangent is positive here, but it's also positive in the first quadrant. So we're going to have those two angles there. So which means that obviously we have the tangent of 2x. So we're going to have 2x is equal to 18,43 degrees plus the period of the tangent is 180 degrees, k being an integer. Right. And now, obviously, this one now is between 0 and 180. So between z, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Okay, now this one is already between 180 and 270, so we want this between 0 and 180. So we're going to take only this right here. And therefore, what are the answers to this? Okay, if you divide through by 2 here, which means that we should have 18,43 divided by 2, it is 9.22 or 9,22 degrees. K times 90 degrees, K is an integer. So 9,22 degrees. And then if you put K equals 1, if K is 0, 90 by 0 is 0, and then you're left with 9,22 degrees. But now if you put K equals 1, so you take the values K 0, 1. If K is 1, then you have 90, 1 by 90, which is 90. 90 plus 9, that, which is 99,22 degrees. So this will actually basically become sort of the two angles that would exist between 0 and 90 degrees, like so. Right, so we got the answer. Next question. For what values of x will this one be undefined? Okay, undefined would mean that if you're looking at the quotient, this is a quotient, g out of f. G is 3, the sine of 2x divided by cosine 2x. Undefined. Undefined is going to happen when cosine 2x is equal to 0. When is cosine 2x equal to 0? You must get the reference angle. The reference angle is arc cosine 0. What is arc cosine 0? 90 degrees. Okay, use a calculator to get this. But one way is to know that cosine of 90 is 0. And in the 90 degrees, sort of the smallest one. The other angles where the cosine is 0 are 90, 270, etc. So we therefore have 2x is equal to 90 degrees plus 360 degrees times k, where k is an integer. Divide by 2, which is 45 degrees plus 180 degrees times K, where K is in Z. Okay, so when K is 0, then you'd have that X is an element of the, okay, when K, you can take K 0, and then obviously the other one is going to be, let's check. When K is 0, you have 45. 180 by 0 is 0, you have 45 degrees. Next one. When K is any other value. Right. So you need to take also extra this one together with the next angle, 270 degrees, because as I was saying, it's just, this one is the smallest, but arc cosine 0 is also 270 degrees, or cosine 270 is also 0. So that you have 360 by K. We're adding the 360 by K. Why do we add 360 times K? Because the period of cosine is 360 degrees. Like the period of cosine and sine is 360. That is why. But here we added 180 degrees. Why did we add 180 degrees in this question? Because the period of the tangent is 180 degrees. All right. We divide through here by 2. What is 270 divided by 2? Is 135. Divide 360 by 2 is 180. K in Z. Right. Okay, if K is 0, X is going to be 135 degrees. Then X is 135 degrees. So obviously both 45 and 135 degrees are between 0 degrees and 90 degrees. So we are done with that question. For what values of X will these be? Undefined. We're looking for undefined. So if they say undefined, what you do? You look at only the denominator. And if they say undefined, you look at the denominator, you let the denominator to be equal to 0, and you get the answers like we did. So when you watch the video, try the questions again on your own. Let's repeat the questions. Okay, let's look at question 4. Use the diagram below to prove the theorem that states that the angle subtended by a chord at the center of a circle is twice the size of the angle that it subtends at the circle. So let's look at this. Need to perform a construction here, like so. Right, and then after that you have 1, 2, 1, 2. Right, construction. You join. The construction is you must join BO and produce. Join BO and produce. Join BO and produce. Angle O1 is B1 plus A. O1 is B, okay, exterior angle of a triangle, because from grade 10 we're taught this. It looks like this. So the exterior angle of a triangle is equal to the sum of the interior opposite angles. So if this one is A, B, and this is C1, 2, we're taught at grade 10 that angle C2 is equal to angle A plus angle B. Why? Because the exterior angle of triangle is equal to the sum of interior opposite, sum of the interior opposite angles. So O1 is B1 plus A. Angle O1 is angle B1 plus angle A. Let's check. Angle O1 is B1 plus A, like in grade 10. This angle is equal to this plus this. Why? Because the exterior angle of a triangle is equal to the sum of the interior opposite angles. So the reason is that the exterior angle of triangle is equal to the sum of interior opposite angles. Okay, that was O1, and then you have O2. O2 is B2 plus C. O2 is B2 plus C. So angle O2 is equal to B2 plus C. Why? Exterior angle of triangle is the same reason. sum of interior opposite angles. Then we have O1 plus O2. Now we want to get the whole angle like the angle AOC. AOC is O1 plus O2. So you then come and say O1 plus O2. So you add them up, this O1 plus O2. But now if you add O1 and O2, you add the right-hand side as well. So you'd have B1 plus A plus B2 plus C. O1 plus O2. Okay, you have B1 plus B2. What is B1 plus B2? Right. B1 plus B2 is actually the same as what? Okay, you can have it written that way. But at this point, obviously, you can see that we added these with that, and you added these with that. But a couple of things you need to consider. Angle A is equal to B1 because this is like a radius, and that's a radius, so the base angles are the same. Okay, this is like an isosceles triangle. Right, so if you're dealing with an isosceles triangle, the angles here are the same as well. So which means A is equal to B1. Right, angle A is B1. Angle A is B1, but also angle C, because this is a radius line from the center to the circumference, the radius, from the center to the circumference, the radius. So the radii are equal. Radii equal. So as a consequence, it means that angle C is equal to B2. Angle C is equal to B2. Angle C is equal to B2. So what is angle A actually? So we can come here and put B1 plus, what is A? Angle A is B1. So which means that here is B2 plus C is B2. So these are base angles. Base angles equal. Okay, because why is A equal to B1? Well, A is equal to B1 because OB is equal to OA, the radii. This is true because OA is equal to OB. Okay, if you have OA is equal to OB, but also you have OC is equal to OB. OC is OB radii. Okay, each one of them is a radius. So now we have angle O1 plus O2. What is B1, B1? It's 2B1. B2, B2 is 2B2. What is this? Take out B2 as 2 as a common factor, B1, B2. Which is O1, this is AOC. AOC. So which means that AOC is B1, B2. So which is ABC. Okay, obviously agree that B1, B2, B1, B2, B1 plus B2 is ABC. This is what you have. So we're effectively saying angle AOC, for somebody who can't see this well, is AOC, which equals 2 times angle ABC. Okay, it's exactly this part. It's exactly this part. So AOC is 2 times angle ABC. Okay. Next. In the diagram below, circle O is drawn. Okay, here's the diagram and circle O was drawn. Okay, get ready, please, to help to try some questions. So S, T, B, and M are points on the circle. S, T, B, and M. Like S, T, B, and M are points on the circle. Circumference of the circle. Right, line MT cuts line OB at E, line MT. MT is a line, guys, so it doesn't bend at E, it's a line, so we can use it as a line MT. But MT cuts line OB, so also OB is a line, folks, All right. MST 67 degrees, so you have that MST 67 degrees. There it is, 67 degrees. Right, OBM is 40 degrees. Right, you have OBM is 40 degrees. Find the size of B1. Find the size of angle B1. Right, we need the size of this one. What is the size of this one? Anyone? Right, so obviously to get this one is pretty very straightforward because you have this is cyclic chord STBM. So this angle here plus this angle here must be 180 degrees. So we're going to say that angle S, angle B1 plus 40 degrees plus 67 degrees is equal to 180 degrees. These are opposite. You can write like this straight away. You don't have time. It's 2 marks. The opposite angles of cyclic quad. Opposite angles of cyclic quad. What cyclic quad is this? Right, this is cyclic quad STBM. Cyclic quad STBM. So which means angle B1 is equal to, so this is 100. So 107 minus that. 107, 180 minus 107, it is actually 73 degrees. So angle B1 is 73 degrees. And we are done. Okay, after you go 73 degrees, you can just write it here to make sure that in case it's necessary in the next question, you are really able to use it. Okay, so B1 is 73 degrees. Next question, determine the size of angle T2. T2. So the examiner is looking for T2, this one. Anyone quickly, if you know? If you know, you know. Right. So want to find the size of T2. Obviously, I know that I can't waste a lot of your time there. But to find the size of T2, we can think together. But first, we know that OMB, angle OMB. Okay, if this one is 40 degrees, this is also 40 degrees. Because these are, this is equal to this. This is like an isosceles triangle. So in an isosceles triangle, the base angles are equal to each other, 40 degrees, 40 degrees. All right. So, which means that OMB is 40 degrees. First, we start by saying angle OMB equals 40 degrees because we have an isosceles triangle. Next, right after we got the OMB, what do we do next? Then we have actually angle MOB. Okay, if you have the triangle, these are 40, 40. If you add everything, we must get 180 degrees in a triangle. So the top angle 180 minus this and that, minus 40, minus 40. So it's 180 minus that, which is going to give us exactly 100 degrees. So this one is actually 100 degrees because if I add this with that, I'll get 180 degrees. So it means that angle MOB, angle MOB, that means angle MOB is actually 100 degrees. Why? Because of angles in triangle. Right, so now let's check. If you have these, wow, this is good news for us because we remember the theorem. If you have this together with this, the angle at center is twice the angle at circumference, or now you can use this version here, this one and this. So, okay, if you move this one across, okay, yeah. So angle at center is twice angle at circumference. So yeah, we're good. We're so good. So in other words, angle MOB is twice T2. Right, but angle MOB is an angle at center, so it is twice angle T2. And the reason is angle at center equals 2 times angle at circumference. So MOB is 100 degrees, 2T2. Okay, divide both sides by 2. It means that angle T2 is equal to 50 degrees. So angle T2 is 50 degrees. 50 degrees. When we're done. Next question. Find the size of angle M2. Okay, if T2 is 50 degrees, now we know that this one is 50 degrees. We need the size of the angle M2. We need the size of the angle M2, this one. What is the size of the angle M2? Obvious. Obvious. Somebody can say that clearly it's obvious. Obvious. Right, first and foremost, you can see that angle M3. You can first find angle M3. Angle M3 is, what is angle M3? Because it is this one plus 73 plus M3. So M3 plus T2 plus the whole of B. M3 plus T2 plus the whole of B. You can say TBM, TBM. So TBM is 180 degrees. So that you can see that we say that these are angles in a triangle. These are supplementary. So we are looking for M3. But T2, we already know that it is 50 degrees. TBM, we already know that it is 73. This angle B, we know about it. It is 73 degrees. So TBM, we know, is actually 73 degrees, and this is 180 degrees. So we need to find angle M3. M3 is 180 minus 50 plus 73 is what? 123. 180 minus 123. It gives us M3 equals 17 degrees. Okay, if M3 is 17 degrees, we come back and we put here 17 degrees. Okay, if this one is 17 degrees, obviously that's what this is. So if it is 17 degrees, what is this? Okay, M2 plus M3 is 40. This is a whole angle is 40. So M2 plus M3 is 40. M2 plus M3 is 40. Okay, you come here and you substitute. What is M3? It's 17 degrees. M2. Okay, so you get this. M2 plus 17. Yeah, right, to continue.
My phone just exited the meeting. Firstly, I couldn't hear you properly, and the screen was displaying the previous question. And I'm trying to like rejoin right now, but it's giving me problems. But I'm still trying.
Okay, I lost another student. So which means that you have 17, and then this is 40 degrees. What is angle M2? Which is 40 degrees minus 17 degrees. What is 40 minus 17 degrees? 40 minus 17 degrees is 23. Right, so we have 17 degrees. So yeah, so angle M2 is 23 degrees. Okay. So we continue. Right, I hope I'm still having the Google. Right. My apologies because I'd hidden that flip up there. But now I hear that you're saying okay, I'm still having Marang. Can you hear me, Marang? I don't know. She was struggling to hear me.
Yes, I can hear you.
Okay, my apologies, because the other student was struggling to hear me. And I can see you still here. Okay, so angle M2 is 23 degrees. So you can watch this and make sure you understand it. So I'm trying to finish the paper. So angle M3 is actually 23 degrees. Angle M2 is 23 degrees. So in the diagram below, like this diagram here, PQRS are points on the circle. So you have PQRS, these are points on the circle. QS and PR intersect at point T. QS and PR intersect at point T. The line from V is a tangent at P. The line from V is a tangent at P. So here we're dealing with a tangent. So this one is a tangent. Right. QRP is 56. QRP is 56 here. RPV 70. RPV 70. Find the size of RST. RST, yeah. RST. Just this angle there. I'm sure that is very, very easy for just 5 marks. Okay, the other student left temporarily. Yeah, there was just, I think, a network issue there. But we need to find this angle S, this one. RST. Any thoughts? Right, obviously a couple of things you can note that angle, this angle, this is a tangent, so you can know that this is 56, so this is also 56 degrees. 70, this one, this is also 70. Is somebody talking to me? Yeah?
No, sir, it's just the music in the background.
All right, okay, that's fine. Are you at the door? Okay, there's somebody who is just knocking on my door. Yes. Yeah, what? Are you saying something? Because I was supposed to go because now I'm still in class. I'm still in class now. Who needs that? Who needs that? You need to leave. Yeah, because I was supposed to go out, you see, but I'm having a discussion in class now. Yeah, but now, you see, I'm having a discussion in class now. Yeah, so yeah, I'll let you know when I'm done. Okay. All right. Okay, my apologies. Sorry, I was speaking to somebody knocking on my door. Right, so find size RST. find size RST. Right, so to find the size of angle RST, you know that this one is 56 and this one is 56. This one is 70 and this one is 70. So which means that angle P1 is 56 degrees because Chenkov theorem. So if you have these here, you have these here. And this angle is equal to this angle there. Right, so it's 10 cot. So this is 56 and that is 56. So angle P1 is 56 degrees. Why is it that angle P1 is 56 degrees? Okay, it is 10 cot, like I said, 10 cot theorem. You can say 10 cot theorem. So now if P1 is 56 degrees, what is angle P2? Obviously, now we need to just be in a position to realize that this is a straight line. So if the tangent is a straight line, so this angle must be a given value so that we get 180 degrees. So which means that P2 is 180 minus 56 minus 70. So angle P2 is 180 degrees minus 56 degrees minus 56 degrees minus 70 degrees. Okay, so because these are on a straight line, so which means that P2 is the same as 54 degrees. So if P2 is 54 degrees, these are angles on a straight line. Angles on a straight line. So which means that angle P2 is 54 degrees. So when you add this plus this plus this, you get 180. Okay. Now this is good news because if you have a figure like so, angles that are, this is like a cyclic quad as well. So this angle here must be equal to this angle there. So they want this angle there. So which means angle S is equal to angle P2. So we conclude here, angle S equals angle P2, which equals 54 degrees. Angle S is equal to angle P2. Okay, angle S is equal to angle P2, which is equal to 54 degrees. And these are angles in same segment. Angles in same segment. So angle S is equal to angle P2. So angle S is equal to angle P2, which is equal to 54 degrees. These are angles in same segment. Next question. So yeah, so obviously now, I mean, they said find the size of RST. You can conclude therefore that RST is 54 degrees. So now there's another question. They said Q1 is 37 degrees. Then explain why QS is not the diameter of the circle. Let's check that one. Q1 is 37 degrees. Explain why QS is not the diameter of the circle. Q1 is 37. So Q1 is 37 degrees. Explain why QS is not the diameter of the circle. Okay, so if you have therefore that Q1 is 37 degrees, explain why QS is not the diameter of the circle. Right, so Q1 is 37 degrees, and you need to explain why QS is not a diameter. Okay, if QS would be diameter, it would mean a couple of things. Because this angle here, like so, an angle here is going to be equal to an angle there. So if this one is 37 degrees, this one is also 37 degrees. 37 degrees, 37 degrees. Right. So And if this one is 37 degrees, if you add these two guys, what do you get? If Q is the diameter, it must be 90, but this is not 90. So that is the reason we state there. So we then say that angle R1 is equal to 37 degrees because these are angles in the same segment. Angle R1. Angle R1 is equal to 37 degrees because these are angles in same segment. So, and if that is the case, we make the observation that angle R1 is that. Therefore, what is QRS? The rest of this angle. The rest of this angle is 56 plus 37. So QRS is 56 plus 37. Right, therefore QRS is equal to the sum of the angles. Let me remember, 56 and 37. So this is 56 degrees plus 37 degrees. And this is the same as what? This is the same as 93 degrees. Okay. But now if it's a diameter, then a diameter subtends an angle of 90 degrees at the circumference of a circle. So if this is a diameter through the center, oh, this angle must be 90, but this one is 93, it's not 90. But so that's how we write it. But for QS to be the diameter, the size of QRS must be equal to 90 degrees. The size of the QRS must be 90 degrees. Hence, QS is not the diameter. Hence, QS is not the diameter. Hence, QS is not the diameter. So we continue. Okay, so if you look at question 5, in the diagram below, A, B, C, and E are points on the circle. A, B, C, and E are points on the circle. AE and BE, AC and BE, AC and BE intersect at F, like so. D is a point outside the circle. D is a point outside the circle. CD and DE are drawn. CD and DE are drawn. CD and DE are drawn. Right, so we have that ABE is X. ABE is X. Right, so if ABE is X, we come here and say ABE is X. So we're going to put X here. Right, so we have BEC. Right, so if you have BEC, BEC is Y. So BEC is Y. BEC is Y. CDE is theta. CDE is theta. CDE is theta. Okay, so if theta is X plus Y, then prove that FCDE is a cyclic quad. Okay, let's look at that one. Right, so obviously, you have first things first to prove this one here. This angle must be X as well because they're angles in the same segment according to this theorem. So this one must be equal to this one. So which means that ACE is equal to X. ACE is equal to X. These are angles in same segment. Angles in same segment. So this is also X, but if you look at angle AFE, okay, we've already said that in the question, if theta is X plus Y, okay, so we are saying the angle theta is X plus Y. So if the angle theta is X plus Y, so we have AFE. AFE is X plus Y. Right, so this angle from grade 10, you know that if you have a triangle like this is this is X, and that is Y, and this is X plus Y. So that AFE is X plus Y. AFE is X plus Y. So if AFE is this one plus this one, exterior angle of a triangle. AFE is this one plus this one. So which means that you have the exterior angle of triangle. Exterior angle of triangle is equal to the sum of the interior opposite angles. So, but we also have that AFE is equal to angle AFE. AFE is equal to CDE, okay, because this one is X plus Y. So you have that this one is X plus Y, but also this one is X plus Y. So we conclude therefore that AFE is equal to CDE equals X plus that. So which means that AFE, here we can see that AFE is equal to CDE is equal to CDE equals X plus Y. Okay, because now if you have that, then it means that this is like a quad. CFED is a quad. So if you have this quad here like this, like so, and this is actually like this, so you can have something like that one. Okay, what I want to draw is a quad like this. So if you have this with this, and then this one goes down, and then this one does this, such that this is X plus Y, but also this is X plus Y. So which means the exterior angle of the quad is equal to the interior opposite. So which means that we have that. So therefore, FCDE is a cyclic quadrilateral. Is a cyclic quadrilateral. Why is it a cyclic quadrilateral? because we have seen that it is actually due to the converse of the exterior angle of cyclic quad. Converse of the exterior angle of cyclic quad. So obviously what we are seeing here is that you have this situation. So you have this equals this. So you have this exterior angle equals to the interior opposite angle. So, and it is exactly what we are seeing here. This angle equals this. If this angle equals this, it means this quad, this four-sided shape is cyclic. So that we have that, what we have proven here. We have that FCDE is a cyclic quadrilateral because we have a situation like the fact that this angle is x plus y. Also, this one is x plus y. Next question. Right, so we still have this shape. And here comes the next question. If AB is equal to AE, if AB is equal to AE, so now we are marking this like this. Okay, if AB is equal to AE, then prove that line AE is the tangent to the circle that goes through. Okay, you need to prove that AE is the tangent to the circle that goes through FCDE. AE is a tangent to the circle that goes through FCDE. FCDE. AE is a tangent. AE is a tangent. Right, so now let's look at this. There's a circle that goes through FCDE. So obviously now we have moreover proven that FCDE is a cyclic quad. Okay, being a cyclic quad, it means it's potentially FCDE. So you have this. Right, so in the end, what you're then having is you have FCDE. There's a circle that passes through those, and we are then saying, prove that AE is a tangent to that. Okay, let's just conclude that one. Right, so we continue. We continue. Right, we continue. We continue. Right. Right, we continue. We continue. Right, so if you have the fact that AB is AE, AB is AE, AB is AE. Obviously, it means a couple of things. It means, therefore, at this point, what do we know about these angles? I mean, we know that this one is X. So if this one is X, that one will also be X. So we know that at this point, angle AEB is also going to become X because this equals this, so the base angles are the same. So, which means angle AEB is equal to X. Isosceles triangle. So if you have ACE, rather, I mean AEB, okay, we have that this one is X as much as this one is X, because these are isosceles angles, and this is rather this is an isosceles triangle, so these are base angles, right? If you look at ACE now, ACE must also be X, because angles in the same segment. This one must be equal to this one. So yeah, this is equal to this. So we have that ACE is X. Angle ACE is X. Why? Angles in same segment. In same segment. So you have that this is X, and that is X. So which means that angle AEB is equal to angle ACE. Yes. By ten-chord theorem, now it means if you have something like this, the angle here is equal to the angle there. So the angle here is equal to the angle there. So this equals the angle there. So angle AEB is equal to angle ACE. Okay, so AEB is equal to ACE because they are both equal to X. Therefore, AE is a tangent. And why is it a tangent? It's a tangent because of the converse. It is the converse of the ten-chord theorem. Converse of the ten-chord theorem. So obviously we're to say that if AB equals AE, so if AB equals AE, then prove that AE is a tangent to the circle that goes through ACDE. So this is the circle. So obviously you have to prove that this angle here is equals to this angle there, and that is the ten-chord theorem. And we've proven that. There's the proof. Next question. Question 6 is a little bit about statistics. Let's just enjoy ourselves. Below is a cumulative frequency graph showing the average number of liters of water used per household per day in a town. Okay, you can see here's the diagram. Cumulative average liters of water used per household per day. Right, other information given, the lowest amount used by any household during a day is 20 liters of water. That is the lowest amount. The highest amount used by any household during a day is 280 liters of water. Right, sketch a box and whisker plot to represent the average number of liters used per household per day. Right, we're going to look at the box and whisker plot. Right, so if you look at the box and whisker plot, right, if you look at the box and whisker plot, let's just analyze it together. Right, so if you look at the box and whisker plot, you need to look at a couple of things that, like, you need to look at your data and analyze your data very, very carefully. Right, so you have the following. What would potentially be Q1 at 1/4 of the highest? So if you divide 800 by 4, 1/4 to get Q1, all right, what do you get? If you divide 800 by 4, you get 2000. So that means that you're at 2000, and at 2000 you would have 50 as Q1. So which means that your box and whisker plot is going to like cut like this. And then now you have this. So this is going to be like Q1. And then Q2 is like half, 50%, median, 50%. So half of 8,000 is like 4,000. And 4,000 is sitting like between 50 and 100. Okay, 50 and 100 is like 25 in the middle. So it's 75 here. 50 plus 25 is like 75. So at 75, it means that at 75, you have that. So this is like Q1. And this is going to be like Q2, which is 75. Right, so you have Q2, which is 75. All right. Okay, Q2. And then now you take 3/4 of the highest one, of 8,000. You divide 8,000 by 4, you get 2,000. You multiply it by 2, you get 6,000. Right. So 6,000 is going to produce 100, and this one is like Q3. So which means 100 is Q3. So you have that. So now, what would be, I'd realized that the lowest would be sitting at about the following, okay? Because if you take the lowest of all of them, right, you can see that between 0 and, now below, at 1,000, we have like 25. And then it goes to approximately 0. It goes to 0, in fact. So you'd have that this is going to go to the lowest point just below 25 here. And then now the maximum value, right? So the maximum value is going to be sitting at what? The maximum value is going to be sitting at what? Right, so the maximum value is going to be sitting at a couple of things, but it's going to be sitting at about, at this point, for example, it's going to be bigger than 275. If you look at 275 there, it's going to be larger than that. This is still continuing. So if you look, it's going to be like somewhere there. It's just up to about 300 there. So you'd have this kind of a drawing, and we have this kind of a drawing. So this would be the diagram, and this will be sort of the box and whisker plot, because you have to sketch the box and whisker plot to represent the average number of the liters in this case, and you have Q3 here. Right, so on average, you'll get this box and whisker plot. Next question. How many households use more than 100 liters per day? More than 100 liters per day. Let's look at this. Right, so if you look at the fact that you're using more than 100 liters per day, so more than 100 liters per day, you can see that it's going to be the cumulative frequency is there, average liters per day per household. So you could see that, therefore, at this point, you would actually look at 6,000 to 8,000. 6,000 here at 100 liters. More is going to be up to 8,000. So it means that the difference between 8,000 minus 6,000 is 2,000. So if they say how many households use more than 100 liters per day, is actually 2,000 households. 2,000 households. Right, describe the skewness of the data. Right, so obviously you can see that this data here has sort of a longer stretch, a longer leg towards the right, and therefore we say it is skewed to the right, or it is positively skewed because of the longer arm towards the right. So we say that it is skewed to the right. Do you want to say skewed to the right, or it is positively skewed? As a result of a price increase, many of the households using in excess of 100 liters of water per day on average intend to reduce their water consumption substantially, because now there's a price increase. Water is becoming more expensive. So now the average, they intend to reduce their water consumption, okay? They don't want to waste water because there's a price increase. And they're saying, okay, let's use less water, guys, because water now is becoming more expensive. Okay, how would this affect the standard deviation? Explain. Right, so at this point, you realize that the standard deviation would increase would rather decrease. The standard deviation would decrease as households using more than 100 liters would lower their consumption. And hence the values will be closer to the mean. The standard deviation would decrease as households using more than 100 liters would lower their consumption, and hence the values would be closer to the mean. Okay, obviously, as they'll be reducing their consumption, the standard deviation would also decrease. Right, next question. The skewness of the data. If they reduce their water consumption, how will the skewness of the data be affected? Okay, so we say that pertaining the skewness of the data would become more symmetrical. Would become more symmetrical as the mean will move much closer to the median. Will move much closer to the median. Or you can say the data would become less positively skewed. Would become less positively skewed. So because the people will be using less water, they're using more before, the data would become more symmetrical as the mean will move closer to the median, or the data would become less positively skewed. Less positively skewed. We continue. I'm trying to get a lot of the questions done before time runs out. Right, let's look at question 7. Information about advertising via pamphlets and television separately is given in the table below. The correlation between the expenditure in rand on advertising via pamphlets X and sales Y is recorded in the first row. Okay, pamphlets are in the first row. The correlation between expenditure in rand on television advertising X and sales Y is recorded in the second table. So right in the second row of the table, we have the television in the second row of the table. Right, which line of best fit would be the most accurate? 2 marks. Which line of best fit would be the most accurate? Okay, here's the answer to that. Okay, but you can see that the pamphlet has 0.95 correlation coefficient, but the television has 0.88 correlation coefficient, and therefore which one be more accurate? Clearly the pamphlets. The pamphlets. The correlation coefficient is closer to 1. Which line of best fit? The correlation coefficient is closer to 1 because of the correlation coefficient. Which line of best fit would be the most accurate? The one of the pamphlets, because it has a higher correlation coefficient that is closer to 1. Next question. If the outliers were removed, did that yesterday, I think, or the day before, how would this affect the correlation coefficient of television and advertising? You remove those values that are very further away from the regression line. The correlation coefficient television, how would that be affected? Right, so it would increase as the values would be closer to the line of best fit. It would increase as the values would be closer to the line of best fit. If you remove the outliers, it would increase the correlation coefficient, like we said yesterday or the day before, as the values would be closer to the line of best fit. Gradient for each line of best fit, how would the gradient be affected? Obviously, the gradient is actually the coefficient like 2 here, the coefficient like 4 there. How would the value be affected? Obviously, it's like A plus BX. So the value of B, how would the value of B be affected? Okay, so we're looking at that one. Let's speak about the pamphlets first. The pamphlets. The gradient would increase. The gradient would increase. Let's look at the television. The gradient would decrease. So the gradient for each line of base fees. So the gradient for each line of base feed, how would that be affected? So obviously we realize that the gradient would, for the pamphlets, it would increase, but for the television, it would most certainly decrease. So we are saying if the outliers were removed, how would this affect? So obviously at this point, you're going to say that for the, if you look at the two, for the pamphlets, it would certainly increase, but for the television, it would potentially decrease, right? Because you see that there is the number of the outliers with high expenditure and low sales. So you can see that now the number of the outliers with low expenditure. So because of these values here, like the number of the outliers with high expenditure and low sales for the pamphlet is 1, high expenditure and low sales, but for television is what? Is 0. Now the number of the outliers with low expenditure and high sales for television is 3. So based on these outliers, you can actually see therefore that the gradient would therefore increase for the pamphlets, okay, and therefore for the television it would most certainly decrease there because of the low expenditure. Okay. Next. Using the information in the table above, explain which method of advertising you would use and why. Okay, let's explain this one. Right, obviously, if you look very carefully, which method would one use here? Which one has the greatest gradient? The television. So, in the correlation coefficient, obviously, it's 0.88 for the television. But the gradient for the television is 4, and for the pamphlets is 2. Would choose the television. We use the information in the table above to explain the method of advertising you would use the television. Would explain. Would use the television as the gradient. As the gradient is steeper, and although the correlation coefficient is lower. As the gradient is steeper, although the correlation coefficient is lower. You can see that. The outliers fall on the high side. They fall on the outside. Like we said, low expenditure. Going to the table. Low expenditure. High sales. So you can predict. You can predict that they are, or they will be an increase. An increase in sales. Will be an increase in sales. Okay. Would choose the television as the gradient is steeper. There's a steeper gradient. And although the correlation coefficient is lower, the outliers fall on the higher side. Low expenditure, high sales, high sales. So you can predict that there will be an increase in the sales. Because of the high sales, we'll choose television. Because of the high sales, because this pamphlet now is having outliers on the low sales. Yeah, this one, high sales, that's where we have the outliers, like 3 of them. So we would choose the television. Because of the high sales, we want to sell more if we're in business. We don't want to sell less. Okay. Question 8. If the sign of 64 is P, determine the value of the following in terms of P. Let's just get started with this. Right, so if you look at the cosine of these, what is the answer to this? Cosine 334. 360 minus 26. 270 minus 26. 360 minus that is in the fourth quadrant where the cosine is positive cosine 26. Okay. So you can choose this one, but let's use this one here. Let's use 180 degrees plus 64. In which quadrant is this? Which is minus 180 plus minus the sine of 64. It's in the third quadrant. So this one is like the cosine of 90 degrees minus 64. Minus the sine of 64 degrees. In which quadrant is 90 minus its interface to everything is positive, but it's a co-function change, cosine by the Coco rule. Cosine changes to sine and vice versa, in which case this is going to change to the sine of 64 degrees. The sine of 64. Sine of 64 is minus p times p, which is minus p squared. Okay, 8 sine 16, cosine 16, cosine 32. What is the answer? What is the answer? So the answer here is when we use the sine of 2 theta is 2 cosine theta sine theta. Or you can say the sine of 2 theta is 2 sine theta cosine theta. 2 sine 16 cosine 16. Cosine 32. Okay, 2, this is sine, it's going to be sine 32, which is 2 times 16. But there's also cosine 32. Okay, so by using this formula, so this is 2 into 2 sine 32 cosine 32, which is 2 into the sine. 2 times 32 is 64. Right. What is sine 64? It's p. So that here we're going to just put p. So this here is like twice p. Right, if sine 43 is a and the cosine of 90 degrees minus k times cosine of 23 degrees plus cosine of 246 sine 23 equals b, then find the value of k if a equals b and k lies between 0 degrees and 90. Okay. So obviously we're starting with the fact that angle A is equal to angle B. Rather, A equals B. A equals B. So which means we have the sine of 43 degrees is B, which is the cosine of 90 degrees, minus K, the cosine of 23 degrees, plus the cosine of 246 degrees, times the sine of 23 degrees. So the sine of 43 degrees is the same as 43. You can write it as 66 degrees minus 23 degrees. Okay. That is 43, 66 minus 23. So now, in which quadrant is 90 minus? In the first, where all these functions are positive, but co-function change at 90 degrees. By the Coco rule, cosine changes to the sine. Okay, but positive in the first quadrant, and then you have cosine 23 degrees. And then you have this one. 246 is the same as the cosine of 180 plus 66. Sine 23 degrees. Okay. So what is happening? Okay, let's look at this one. Yeah, this is the sine of 66 minus 23 degrees. Sine K. The sine of K, cosine 23. And then now you have 180 plus is in the third quadrant where cosine is negative, so it's minus cosine 66. Sine 23. Sine 23 degrees. So which means, therefore, we have this. So if at this point this equals this, is sine this. Now the 23 degrees that we are seeing here on the left-hand side appears here is 23, 23, then 66, 66, which means, therefore, K is 66 degrees. K is 66 degrees. K is 66 degrees. Okay. K is 66 degrees, and that's the answer. Because they said if A is this, sine 43, and B is that, then find the value of K if K lies between 0 and 90 degrees, and K is 66 degrees, and 66 degrees is between 0 and 90 degrees. Next question. Next question, you need to prove this one. You need to prove that this is equal to 2 over cosine theta. Let's take the most complicated side, so let the left-hand side, which is 2 cosine 2 theta, cosine theta, divided by cosine squared theta minus sine squared theta. 2 tan theta. So which means the left-hand side is the same as 2 cosine 2 theta, cosine theta. Cosine squared minus sine squared is cosine 2 theta. Tan theta is sine over cosine, so this one is going to be sine over cosine. Sine times sine is like sine squared theta over cosine theta. The left-hand side is the same as. Okay, so we have the denominator of cosine 2 cancels cosine 2, and what do we get at the end of these? Cosine 2 cancels cosine 2, giving 2 cosine theta plus 2 sine squared theta divided by cosine theta. Cosine theta. Cosine theta over 1 is cosine theta, which is 2 cosine squared theta plus 2 sine squared theta. Yeah, okay. So the top common factor, you have cosine squared theta plus sine squared theta divided by cosine theta. What is cosine squared plus sine squared? It is 1. So this is 2 over cosine theta, which is the right hand side. So we're to prove, therefore, that the left is equal to 2 over cosine theta, and we have proven that this identity, because we started from the left, we maneuvered, we manipulated, and we got 2 over cosine theta, and that is the right hand side. Next question. Right, in the diagram below, we have the following. We have the following. Right, so FW is 6 units, FW is 6 units, FG is the square root of that, and GWH is 45 degrees. GWH is 45 degrees. Calculate the length of GH. GH, we're interested in finding this one. Right, so we can use the cosine rule, so we can see that the angle FWG, the angle FWG is 135 degrees, because this must give us 180 degrees with the 45. So FWG is 135 degrees. Right, so after that, we can actually be able to use the trigonometric sine rule, which means we can be able to see that the sine of FGW divided by 6. Okay, so the sine of FGW, right, which is the sine of this angle, divided by 6 is equal to the sine of 135. Sine of 135 over the square root. Okay. All right, you multiply everything, you can get that FGW here. You cross multiply and use shift sign, and the angle is going to be 23.2 degrees. So FGW is 23.2 degrees. Right. Then we have WFG. FGW. FGW, we've already got that one. And then we have WFG, this one here, must be 21.8 degrees, because these are angles in a triangle, please. So we have that angle WFG is actually equal to 21.8 degrees. Why? Because this angle is 180 degrees minus 135 degrees minus 23.2 degrees. Okay, which is this. And then now we have got the angle. Sorry, we've got the angle, this one. Let me see. Right, we've got the angle WFG. WFG, which is this one. And then we need now to find this one, so we can use the sign and say the trigonometric sign of 21.8 degrees. So we can find the sine of 21.8 degrees, which is GH. over, which means GH. Okay, if you cross multiply, if I assign this times the square root of that, you'd get 4 units. Okay, so the length of GH is 4 units. In this diagram, the length of GH here is exactly 4 units. Next question. Okay, we have this diagram here. You have that AFC is drawn. AFC is drawn. B lies on AC. Here it's B on AC, and we have with D and E on CF, D and E on CF. Right, BD is parallel to AE, BD is parallel to AE, and BE is parallel to AF. Right, we have BE is parallel to AF. CB, the ratio of CB to CA, the ratio of CB to actually CA is 5:9. Right, the length of CA is 18 units. Find the length of BA. The length of CA is 18 units. Find the length of BA. Right, so we can easily get that one. So yeah, we can use simply this ratio here, because now you have CB, right? You have CB, the ratio of CB to CA is 5:9. So if you look at CB to CA is 5:9, CB to CA is 5:9. CB to CA is 5:9. So, well, it means that you have CB to CA is 5x over 9x. If you like, you can write it like that. Right, but obviously you already have that CA is 18 units. So if CA is 18 units, you can be able to find CB. CA is 18 units, so you can put it here and be able to find CB, for example, and then you find BA. Let's find these. CA is 18. CB over 18 over 9x. CB is 5 over 9, 18. We divide by 2, by 9. 9 goes 2 times there, which is 10. That gives us CB to be 10. Okay, if CB is 10, so in other words, we have that CB is 10, then we have that the whole of CA is 18. The whole of CA is 18. So now we're interested in AB. So it is clear at this point that CB plus BA is 18. What is CB? It is 10 plus BA, which is 18. And what is the answer? Which means BA is 8 units. 8 units. BA is exactly 8 units. BA is 8 units. Okay, let's find the ratio of the areas here. The ratio of the area of triangle BDC over B8. So if you look at BDC, the area of these is half base by height. So it's half CD times the perpendicular height. So half. Goodness me. It's half CD times the perpendicular height. Half. What is the area of BED? BED. So you can choose a height like this for the triangles. So that if you look at BDC triangle and BED, they have the same height H. So that the area of the triangle BED is half the base DE, which is half DE times the height H. Yeah, we can put perpendicular height here. Okay, so what is the answer to these? What is the answer to these? The triangles have the same perpendicular height. So in other words, this ratio here is going to be CD over DE. What is CD? What is CD? Right, so obviously we're dealing with CD to DE. Right, because this is prior to that, you've already got BA. What did you get BA to be? You got this one to be 8. So which means, therefore, this is going to be the ratio of CD to that is going to be like 10 to 10 over 8. 10 over 8. You divide by 2, 5 out of 2. Divide by 2. 5 out of 4, excuse. 5 out of 4. 5 out of 4. If the length of CF is 45 units, just look, length of CF is 45 units. If the length of CF, right, if the length of CF is 45 units, right, here is C and here is F, and we're saying the length of these is 45 units. Find the length of DE. Find the length of DE. Okay. We need the length of this one. So the way to do this, you can split CE into the CE, you can split it to like 5 out of 4. Right. So split CE to 5 out of 4. Split CE to the ratio of 5 is a 4. Right. So if you split CE to the ratio of 5 is to 4, like we saw, and then you're going to have the ratio of DE to CE (5 out of 4). So the ratio of, so this would imply that the ratio of DE to CE DE, the ratio of DE to CE is going to be 4 out of 5 plus 4. DE 4, CE is 5 plus 4, 9. 4 out of 9. So this is going to be like 4 out of 9. Okay. And what is DE? DE over CF. Okay, so what is DE over CF? Let's check. The CF here is CF 45. And then DE is actually having a 4 here. So if you look at the ratio of now DE to CF, because obviously we have the 45 there. Right, obviously you can do that in a couple of ways. Let's just spend some time to do the ratio of DE to CF. Let's do that. DE. Right, so the ratio of the DE now, you can see that this one is 4. And obviously this one here is going to be exactly, it associated the CF is associated with 45. But obviously then there are a couple of things to consider at this point. What would this be? Like EF, what would EF be at this point? What would EF be at this point? So that in the end you have that, CF is 45 units. So that CF is 45 units, you need to find the length of DE. Right, so let's look at these very, very carefully. We did these together, but let's look at it. So you would say, for example, if you look at DE together with, so this one is going to be like 9, and then you can find this other one. So if this is sitting at about 9, then what would EF be? Right, so that would be the same as the following. Okay. So the ratio of DE to CF, it's going to become, okay, you can always check that, it's going to become 20 out of, it's going to become 20 out of 81. If one considers the use of these two, it's going to be 20 out of 81. Right, from which we're able to find the fact that CF you already know. Can always explain this obviously from those ratios, but now at this point it means DE is going to become, because CF is 45, so this is 20 out of 81. You multiply by 45. Okay, we have 9 going 5 times there. 9 going 5 times into whatever, 45, etc., and 9 times there. So you could have 5 times there, 5 times 20 is 100. 100 out of 9. So which means that DE itself is 100 out of 9, approximately 11.11. Okay, try to digest that, but yeah, using proportionality, you'll get that. But yeah, I'm trying to really conclude this discussion. We do not have lots of time left. I'm not sure we can finish this. Our time is almost up. Our time is almost up. Okay. I will. All right, I'm still here. Okay, this question 10. In the diagram below, second center O passes through F, S, and H, and there's G. And you have, okay, DF and DS are tangents. So you have DF, and these are tangents, and therefore DF and DS are tangents, so they're equal because they're drawn from the same point. The circle DS is parallel to SG, so you have DF is parallel to SG. Okay, these are parallel to each other, and FOH intersects SG at R. FOH intersects SG at R. Okay, prove that these triangles are DSF is similar to OHG. Okay, SF is similar to OHG. Right. Let's prove this. Let's prove this. Let's prove this. Right, to prove this, a couple of things are very important. So we're going to realize one thing, that angle F1, for example, is equal to angle what? Angle F1 is equal to angle S3, because F1 and S3 are equal. These are base angles of the isosceles triangle. So we have that angle F1 is equal to S3. Tangents. Tangents from tangents from common point. Tangents from common point. So angle F1 is equal to angle S2. Angle F1 is equal to angle S2. These are angles in Z, alternate angles. F1 is equal to S2. So these are alternate angles. Alternate angles. DH is parallel to SG. Okay, so we have that this angle here, this angle is equal to this angle there. F1 is also equal to, these are equal, but also equal to this. Oh, but angle S2 is equal to angle H1, angles in the same segment. Commented about this theorem here. So yeah, these S2 are and S and H1 are equal. So angle S2 is equal to angle H1. These are angles in the same segment. In same segment. What is the conclusion? What is then the conclusion out of this? Angle H1 is equal to, angle H1 is equal to G1 and G2, because this is like an isosceles triangle. So H1 is G1 plus G2. So angle H1, G1 plus G2. Radii. Isosceles triangle. Okay, as a conclusion, it follows therefore the triangle DSF is similar to the triangle OHG, angle, or you could comment that angle D. Now angle D is equal to angle O1. Angle D equals angle O1. That angle? That angle? Angle D equals angle A1, which means you have angles in a triangle. Next. Want to prove this one? Want to prove this one? Okay, to prove that two times ds, df is this. Right, so from since those triangles, like we have proven this result, we have proven that DSF is similar to OHG. Triangle DSF is similar to triangle OHG. Proved in A above. Okay, because this is proved in A, you remember what I said, so you can do the first two. DS over OH is equal to SF. SF goes with HG. And then you can go to DF goes with OG. Okay, and this is the proportionality theorem. This is the proportionality theorem. And then if this is true, we're interested in proving that result. So we're gonna just consider DF and the OG together with the SF part, this one. So we're gonna say DF over OG is SF over HG. Which is OG SF over HG. Okay. Right, but what do we know? Right, let's look at FH. Let's look at FH. FH, if you divide the diameter, FH is through the same as the diameter. FH divided by 2 is going to give you OG, the radius. But OG is FH divided by 2. Therefore, okay, you're here. So if you have this, which means that wherever you have with OG, therefore 2 times DF is actually SF, which is this one, multiplied by FH. Because half FH is OG. You divide by HG. 2 times DF is SF times FH over HG. Okay, that is what they asked us to prove, and we have proven that. Okay, we are continuing. We continue. All right, so now we have this diagram here. We have this diagram here. Okay, yeah, we have had this diagram, so okay, part of the question paper. Let's look at question 11 and then question 12, and then we are done. Question 11. Okay, in the diagram below, the given shape is enclosed by line AB, line BC, and part of the circle with center O. AB is the square root of 13, the square root of 29, and 8 units. A, K, and C are points on the circle. All right. A, K, and C are points on the circle. Right, EK is perpendicular to AC, goes through O. Okay. Now let's answer the questions. Okay. Okay, so if OE is 0.8 units, okay, I'm having Lindsay joining. That's okay. Right, if OE is 0.8 units, if OE is 0.8 units, find the length of EK. Right, so the couple of things that we know, like, what would AE be here? AE. Okay, because this whole thing is 8 units. This is going to be 4, and this is going to be 4 units. Okay, I'm going to start with you, Lindsay, just now. So, yeah, so which means, therefore, that AE is going to be 4 units. I'm trying to get to the end of this question paper. So, all right, AE is going to be 4 units because of the line from center perpendicular to chord. Line from center perpendicular to chord. What about OE? OE. So OE is, according to this, 0.8 units. OE is 0.8 units. What about OA? OA. Right, if you look at OA, what is OA? All right, so you can use the Pythagoras. Okay, this is 90 degrees. This is 0.8, and this is 4. So if you use Pythagoras theorem, you'll be able to see that this one. Okay, I had lost Lindsay, which means that OA is equal to 4.08 units. Use Pythagoras. It's just by using Pythagoras theorem. Pythagoras theorem, okay? Right, if you use Pythagoras theorem, you get these. Okay, yeah, Lindsay, you are in the right place. Please do not think that you are lost. You are in the right place. We are finishing now our discussion, and then we are starting with you. So that we have EK, and EK is 4.08, which is this one. EK. Okay, so this is like a radius, this. So if it is 4.08, also this one distance from here to there is like a radius, so it's also 4.08. 4.08 plus 0.8. 4.88 units. So now the next thing is, okay, you have this. This is the diagram. Okay, obviously asked us here to find the length of EK. Okay, we're starting now, Lin Cui. Okay, we're starting with you. Right, EK, we found it to be 4,88. You can see what you did with your, just one way to do the question. Just one way to do the question. I'm concluding, please. I'm just at the end of the question paper so that every question is answered. Right, you cut out the shape above and fold it along the dotted line AC. You cut it out, and you fold it along the dotted line AC, so that ABC is on the vertical plane. So that triangle ABC is on the vertical plane, and the circular shape through points A, K, and C, A, K, and C is on the horizontal plane. A, K, and C is on the horizontal plane. Calculate the straight line distance from B to K. The straight line distance from B to K. B to K. Once it has been folded. Right, so let's look at this particular question. Right, so obviously you cut the shape above and fold it along the dotted line. You fold it along this dotted line, so that triangle ABC is on a vertical plane and the circular shape on the horizontal plane. So you fold it here so that this triangle is like up, and then these guys here, the ACK, are on the horizontal plane. And then now the question is, you need to find the distance from B to K. B to K. Right, so to get that one, the distance from B to K, the distance from B to K, like so. Right, so to get the distance from B to K, we're gonna use the rules that we know. What rules do we know? We're gonna use the cosine rule to find the cosine of, first, the cosine of BAC. Right. You must find first the cosine of BAC. What is the cosine of BAC? By using the Pythagoras, the cosine rule. Cosine rule. So you want to find this angle. Okay. You have this. And you have ABC. ABC, you want to get this one. But you already know this is square root of 13. The square root of 29. And you already know that this one is 8. So how do you find the size of this angle? We're going to use the cosine rule. So this one here is like small a, small b, small c, which means that we want to get this one. So we're going to use a squared is b squared plus c squared minus 2bc cosine a. Okay, this is called the cosine rule. So we want to find angle A, so 29. B is 8 squared, square root of 13. 2b is 8, square root of 13, cosine A. So, which means cosine A or you can say the angle is BAC. Let's keep it as A. Cosine A is going to be the same as 29 minus 13 minus 64 divided by minus 2 times the square root of 13 times 8. Which means that you have BAC is equal to 33,69 degrees. Okay. So this angle here is that, which is angle A is equal to BAC, which equals that. Okay, well, we are starting now, Lindsay, please. So that now you have the sine of 33,69 degrees. Right. Okay, the sine of this. So you'd have the sine of this angle, which is equal to the height of B over the hypotenuse. So if you fold it, there's going to be some height here like this. So there's going to be the height of B, the sine of this angle is going to be the height of B over the hypotenuse. Is the height of B over the hypotenuse. Okay, we are starting lane 3. We are starting lane 3, which means we have the height, which means the height of B is actually equal to, okay, if you multiply the sine of the times the square root of 13 and use a calculator, you'll get that the height of B is actually 2 units. And then after that, we can get the what is wanted, because the examiner wants what? The straight line distance from B to K. Right, so the straight line distance from B to K. So you're gonna do and calculate the cosine. Cosine of 33,69. Okay, focus on the diagram. This is going to be point below B. Point below B divided by is adjacent of hypotenuse. Adjacent of hypotenuse. So the point below B, if you want to find the cosine of these, is going to be the point below B is adjacent to these over hypotenuse. Right, and you use a calculator, which means the point below B is 3 units. The point below, if you take this and multiply by the square root of 13, cosine this times square root of 13, you get 3 units. Okay, I'm finishing. So the point below B is 3 units. So the examiner, so you got 3 units here, you got like 2 units there. Okay. Next. Obviously, what the examiner wants here is the straight line distance from B to K. So we can get now the distance from K to new point. Right. So in other words, this distance from K to new point. Right. So obviously, because you know this one is 0,8. Okay, got that this one is 0,8 and this one is 4. I'm finishing is 4,08. This is 0.8. So you add these two guys. So the distance from K to new point. Right. So in other words, we're interested in therefore finding the distance. Let me write that one down. The distance from K to a new point. Which is, so it would be 1 squared plus the 4,08 plus 0,8. So yeah, which is 4,88 squared. So using a calculator, this is going to be 4,98 units. Therefore, from B to K, once the fold has been made, is. So this is going to be the square root of 2 squared plus 4,98, which is 5,37. Distance from K to the new point. Okay, I'm finishing, please. So that the distance from B to K once the fold has been made is 2 squared plus 4,98 squared, which is 5,37 units. Okay, I'm pushing, I'm just running, please forgive me. So that is the answer to the question. So you can always ask if you have any question. Okay, I want to finish the last one. A farmer uses a drone to check his fences for any damage. The drone flies in a perfect circle. Here the drone flies in a perfect circle like so. Okay. And passes directly above points A, B, C. Points A, B, and C. A, B, and C. It passes directly above. Points A, B, C, and D are on the same horizontal plane. A, B, C, and D are on the same horizontal plane. The D lies on the x-axis. Here it is. X-axis is D, so D is there. At present, the angle between the line AD, and the x-axis is 45 degrees. Okay, 45 degrees is here. Determine the current coordinates of point D. Determine the current coordinates of point D. Let's find the coordinates of point D. The current coordinates of point D, okay? What are the coordinates of this point? One way to find the coordinates of the point D is to actually attempt to deal with the line AD, and the line AD can be seen as a line like so, making an angle of 45 degrees there. Okay, these angles are the same because they are vertically opposite angles, and that means that we can be able to deal with the line AD. Line AD. The tangent of 45 degrees is M. Tangent of that is 1. So that it passes through this line AD. Okay, so yeah, what I'm saying here is line AD. Line AD, line AD passes through A with coordinates 1 and minus 2. Y minus y1. M into x minus x1. x1, y1. Y minus into minus 2. The gradient is 1. X minus 1. Which means it is x, and if you bring 2 to the other side, it becomes plus 1. Okay, that is the line AD we're talking about. Let's see now. Okay, this is plus 2. So in particular, it's going to be minus 3 here. So that we have y equals x minus 3, because this is plus 2, it becomes minus. What are the coordinates of D? So to find the coordinates of D, at D you have the x-intercept. You let y be 0. Okay, if y is 0, you're here. Y is 0. 0 is x minus 3, which means x is 3. The coordinates of D are x is 3 and y is 0. Okay. We're supposed to determine the coordinates of the current coordinates of D, and they're 3 and 0. Okay, we're starting lane 3, we're finishing, we're running. Calculate the size of angle ABC. See? ABC, what is the size of this angle? Right, we can find the gradient of the line AB. And then the gradient of the line BC. So AB, let us see. Okay, B is minus 2, 1. A is 1 minus 2. So, okay, we have the gradient of AB, which is y2 minus y1 over x2 minus x1. What is y2? So yeah, it's x1, y1, and this is x2, y2. We're starting lane 3. y2 is 1, y1 is minus 2, divided by x2 is minus 2, x1 is 1. And this is 3 over minus 3, it is minus 1. So the gradient of these, okay, so we have that the gradient of these is actually minus 1. So now we have the gradient of BC minus 2, 1. Okay, let's see. B is minus 2, 1. Minus 2, 1, and C is 2, 5. With the gradient of BC. So this is x1, y1, x2, y2. y2 is 5 minus y1 is 1. x2 is 2, x1 is minus 2. So what's the answer? This is 4 over 4, which is 1. Okay, well, the gradient of AB is minus 1, and that of BC is 1. So that the gradient of AB the gradient of BC, okay, we can see that the product is -1. If you multiply 1 and so this means that the angle ABC is 90 degrees. That means the angle ABC is this one is 90 degrees. So how far to the point to the right must D be moved along the x-axis so that the drone will fly directly above it? Right. So we continue. So now C would be the same as what? How far to the right must D be moved along the x-axis so that the drone will fly directly above it on its circular path? D be moved along the x-axis. Far to the right must D be moved? How far to the right must D be moved? So if you're moving D to the right, how far must it be moved so that the drone flies directly, will fly directly above it on its circular path? So in other words, on its circular path, this D must be moved. But how many units must D be moved like that? How many units must it be moved? Okay, so the couple of things that you need to obviously consider at this point. It is the fact that angle CDA is 90 degrees because this one is 45 degrees. And if that is 45 degrees, and you want these to be you want these to be sitting exactly here. So if this is sitting exactly there, this is already 90, so that is going to be 90. So CDA is going to also become 90 degrees, so that 90 plus 90 is 180, the opposite angles of a cyclic quad. Okay, we are finishing Lin Tsui. Okay, so that angle CDA is actually 90 degrees. Why? Because you have the opposite angles of cyclic quad. Yes, please, my dear. Hello, my dear. All right, my dear. Okay, so we continue. Just 1 minute, I'm coming. All right, yes. All right, my dear. Okay, we continue, guys. We continue. Continue, folks. Okay. So CDA, if you move this here, you move it like so that it's on the boundary of the circle, then you're going to have opposite angles of a cyclic quad. 90 plus 90 must be 180, so it must be 90 degrees there. But how far must it be moved so that such a thing happens? The gradient of CD. What is the gradient of the line CD? Let's check. Okay, so obviously at this point when this is removed, we have something like this. The coordinates of D would be x and 0. So what is the gradient of CD? So the grade of CD, okay, C has 2, 5, D has x and 0. C has 2 and 5, D has x and 0. This one, gradient is y2 minus y1 over x2 minus x1. x1, y1, x2, y2. What is y2? It is 5 minus y1, 0. x2 is 2 minus x1, x. So you get this. What is the gradient of AD? Let's check. So A is going to have the coordinates 1 and minus 2, dx and 0. One and minus 2, dx and 0. Okay. What is the gradient? Same formula, y2 minus y1 over x2 minus x1. What is y2? x1, y1, x2, y2. y2 is 0, y1 is minus 2. x2 is x, x1 is 1. So this one is equal to 2 out of x minus 1. Right, so after this has been done, we want this angle to become a 90-degree angle. Want this one to become a 90-degree angle. So, okay, we're finishing, Lindsay, so that we have 5 out of 2 minus x. Multiply by, okay, 5 over 2 minus x, because this one is 5 divided by 2 minus x, but it is multiplied by 2 over x minus 1, and the result is minus 1. So that in the end, then you have x squared minus 3x minus 8 equals 0. All right, you can use the quadratic formula. And then say x is minus b plus or minus the square root of b squared minus 5c out of 2a. And therefore it's minus b, which is minus into minus 3, plus or minus the square root of the b squared, which is minus 3. You square these, minus 4. A is 1, c is minus 8. Over 2, a is 1. Okay, if you simplify this one, simplifies to x equals 4,7 by using a calculator, or x equals minus 1,7. So now what can d be at this point? So the conclusion is going to become that d needs to move 1,7 units to the right. D needs to move 1,7 units to the right. And then let's see what else is left. Okay, this was the end of the question paper. So thanks obviously there to Marang. Okay, Marang has been here. Right, so yeah, if you don't understand something, please, we can always check that. But yeah, I'm gonna post the video after our discussion with Lindsay. So yeah, we're good for today. So thanks, Marang, and I'm gonna actually end the recording, but we still